Sometimes the right triangles we solve are not in the same plane, meaning it's not just a perfect piece of paper that you could just sort of show your work on. So it's going to be a bit trickier to draw. We have a diagram here, but we'll sort of separate and draw some triangles within that as well. So example 3 says, from the top of a 90-foot observation tower, so the tower right here is 90 feet, a fire ranger observes one fire due west of the tower at an angle of 5 degrees and another fire due south of the tower at an angle of depression of 2. So he's on the tower, there's an angle of depression of 5 as he looks down to this fire. It's hard to see, but there's a little fire picture there. And then he looks this direction, and it's an angle of depression of 2 degrees. Again, not drawn to scale, this angle, this diagram rather. How far apart are the fires to the nearest foot? So my goal is to know this distance here. Okay, so some key information in here as well is that the fire is due south. Sorry, I should have read this part west first. So one fire is due west and one is due south. So that means the fires are actually, when he's looking here, that this is actually a 90-degree angle right here. So it's a little bit hard to tell because it doesn't look like a 90-degree angle. Okay, but if you were looking, you would turn 90 degrees. He would stand here and then he would turn 90 degrees. The other thing is, because this is a tower and this is the horizontal, this is a 90 degree and this is a 90 degree. So these are all right angles. It would be easier again with three-dimensional object to sort of see it. You would have like, this is the tower, right? You've got your ground here with this horizontal. So from the ground to the tower is 90 degrees, okay? And also on the ground, the fires themselves, right? The way he's looking at it is 90 degrees and you're trying to figure out this distance along here. Okay, so that's sort of, and if I were to maybe grab like another pen or something here, right? The tower would be here. So see how there's actually there's 90-degree angles between all of the connections of the pens. Okay, so what we're gonna need to do is figure this out. Right now I don't have any information about this bottom triangle. So I need to find this side and this side. So let's call this X and this side Y. Okay, so this is 90 feet, remember, in here. Now it's a little bit hard, it gets a bit squishy in here. So I'm gonna redraw this triangle and not make it sort of two-dimensional. So this triangle right here, where the fire is down at the bottom here. So this is my X that I'm trying to find here. This is my height of 90. This is my right angle. Okay, so when he's looking, the angle of depression here is 5 degrees. So the actual angle in the triangle has to be 85 degrees because that's a 90-degree distance right there. Okay, so we're going to use, to find X, this is opposite and this is adjacent. So you're going to use tan. So tan theta is opposite over adjacent. Okay, let's have a look here. We're going to put in our tan 85 degrees. Opposite is X over 90. Let's do our cross multiplication. X is equal to 90 times tan 85 degrees. We're going to put that in our calculator. 90 times tan 85. Okay, 1,000. Wasn't used to seeing a comma in there. 1,028. All right, let me just, I don't want to run out of room here. Let me just slide this down. There we go. 1,028.7047. Oh, because that's not our final answer. I want to write down a little bit more feet. Okay, I've got to go through the same step, but to find the Y. So I'm basically redrawing this triangle right now. So it's still that 90-foot tower, but we want to find Y. Now in this one, this is 2 degrees, clearly not drawn to scale. So within here, 90 minus 2, this must be 88 degrees. Okay, so we're still going to use tan because this is still opposite and adjacent. Okay, so tan 88 degrees is equal to Y over 90. Again, cross multiply, Y is equal to 90 times tan 88 degrees. Put that in your calculator. And we get 2,577.262795 feet now. Okay, even if you didn't rate every one of those decimals. Okay, so now what's going to happen is we know X and Y. Okay, so now I need to draw this triangle. All right, I'll maybe call this side Z. All right, I'm gonna have to move the paper down here. This side's a bit farther since this is a longer side, so I'm gonna try and draw it a little bit more accurately. So, right, this was side X, so that was our 1028.7. This was X, this was Y, so this is 2577.2, etc. We want to find this side. So again, I'm just going to call it Z. All right. To do this, if you know two sides, use Pythagoras theory to find the third side. So we have C squared is equal to A squared plus B squared. So Z squared is equal to 1028.7047 squared plus 2577.26279.5 squared. All right. When I do that, okay, oh, I guess I accidentally hit clear on my calculator. Well, I'll just have to type in I would have had that in my calculator and just squared it, but I'll just have to type this all in. Okay, so type all of this into your calculator. I'm just going to make myself have some more room. So go ahead and put all of that into your calculator. And when you do that, Z squared is equal to a pretty large number here that we're dealing with. We're going to have to still square root this, but you're going to have that. So then when you square root this, square root that, right, to the nearest foot will be your answer. And again, you know where your square root button is on your calculator.